Hi everyone, today we'll solve Leetcode problem, remove nth node from end of list in C programming language. We'll start by understanding the problem with diagrams, then we'll break down the logic, and finally we'll implement the solution in C. So let's get started. We're given a singly linked list and integer n. Our task is to remove the nth node from the end of list and return the modified linked list. So here is an example. We have singly linked list and integer n. If n is equal to 2, it means that we need to remove the second of list and return its head. So let's get started. So let's say n is equal to 2. We need to remove this node. So how can we know that this node is actually the second of list from the end of the list? To do that, we need to use two-pointer technique. The idea is simple: maintain a fixed gap of nodes between two pointers. So we have two pointers, fast and slow. Okay, we need to move fast pointer n plus 1 steps ahead than slow. So how can we explain this? Slow is right here, fast is right here. We need to keep the gap between two pointers. So we move both of pointers. If fast is here, then slow will be here. If fast is here, then slow will be here. If fast reaches to the end, slow will be show, slow's next will be show, the node that we want to delete. And here we update the next pointer and free the memory. So here's our code. First, we create a dummy node that points to head, and we create two pointers, fast and slow. Both of our initialized a dummy node. Here we open for loop to move the fast pointer n plus 1 steps ahead than slow pointer. And then we open a while loop to move both of our pointers, fast and slow. It will work until the fast pointer reaches to the end. Since fast and slow maintain a fixed distance, when fast reaches a null, slow will point to the node just before the one we need to remove. Now we delete the target node. We create a temp pointer and make it equal to node we want to remove. Then we update the slow's next to the slow next to skip the temp, making it point directly to slow next. And finally, we free the memory. So let's move on. We have created new node, we call it new head, and making it equal to dummy next. Since dummy was pointing to the original head, dummy next now points to the updated linked list. And then we free dummy. Dummy was dynamically allocated using malloc, so we must free its memory to prevent memory leaks. This does not affect the list since dummy was just a placeholder. And then we return the new head. Here we have a create node function, and it returns a new node. And then we have print list function, and here's our main function. Alright, here's our final code. Now let's submit it and check if everything works correctly. As you can see, our code runs successfully and passes all test cases.